it's more the vision of Orange. I mean, I have participated in elaborating it, so it's also in line with my vision, but it's mainly the vision of the company. And hopefully I will bring some operator perspective here. So many of the points that I will discuss have been already partly addressed during the panel this morning, but hopefully there will still be some that will be new. So these are the elements I will address in my talk. So first, I mean, that will be very quick. What's our definition of 5G, which actually I already given this morning. Then an overview of our requirements as an operator. Then a short list of what we see as the key radio technology components. And then something new that we discussed only a little bit this morning. It's about architecture, and here I will outline in a very high-level way what is our proposal for the 5G architecture. And I will end with a focus on those ultra-low-cost networks that we briefly discussed this morning. So about the vision that we set out this morning, for us, 5G is the technology that we will deploy and operate during the next decade. And contrary to the previous technologies, it's not only about air interface, it's about having several air interfaces, including 3GPP and non-3GPP, and here we think in particular to wireless LAN, all integrated into the same network, using a convergent core network between different radio accesses and also wireline accesses. So in terms of the services vision, I will be very brief on that because I think we addressed most of them already this morning. One that maybe we didn't address is the service in very crowded areas. Here we refer to stadiums or music festivals where you have hundreds of thousands of people in the same area. And usually what happens in those places today, unless you have a dedicated small cell which are deployed, is that you cannot pass any voice call or even SMS are very difficult to go through. So here we want to still to provide several megabits per second to all the users who wish, for instance, to upload some video streaming about the event. Another one is that we would like the services to be available everywhere, including in the transport. And OK, you can already have internet in your car, in the high-speed trains. But the next step is to bring also connectivity, internet connectivity in the airplanes. I mean, in the US, you have already that with Wi-Fi. And we would like to bring 4G and 5G in the airplanes as well. And as I said this morning, the most important one, or at least one for which we need really to have a special care, is the unknown one, for which we need to have forward compatibility and flexibility in the network in order to be able to have the technology addressing those use cases, even though we have no idea today about what they will be. So on this slide, you have the overview of our key requirements for 5G. So they are organized in 3 families: network, user experience, and enablers for new businesses. And the key point here is that those requirements, they are ordered according to our priorities. And you can see that our 3 top priority requirements, they are not capacity, they are not higher data rates, even though those are there also. It's low power consumption, cost efficiency, and flexibility for future evolutions. That's a key change versus the previous technologies. I think we have addressed most of the other ones this morning. Maybe one that we didn't discuss is about the control of the electromagnetic field exposure. This one is a bit sensitive. Not everyone likes to talk about it. But of course, there are regulations to limit the exposure of the humans to the radio waves. And all the systems, they have to comply with that. But beyond the international regulations, you have also some local administrations that can set very aggressive limitations for the exposure levels. And it happens that for the 4G deployment in Brussels, we had a lot of trouble because the Brussels town administration set very hard limits for the allowed exposure, and actually it delayed by 1 year the deployment of our 4G network. And obviously it doesn't make sense to design a very nice technology if in the end you cannot deploy it because of some local regulation. So we need to be careful right from the design of those technologies about being compliant with those regulations. Now moving to the user experience, our top requirement here is to provide an homogeneous user experience across the coverage area. And by homogeneous here, we don't mean equal, because we all know that from the system efficiency perspective, providing the same data rate to everyone is not the most smart thing you can do. So still, the users which are in good radio conditions, they will always get a better throughput than the ones which are at the cell edge. But still, we would like to bring some consistency and to reduce the gap between the best users and the worst ones. I think we addressed the other ones. I will come back to the enablers for the new business when I will discuss the architecture. This is very much architecture-oriented. Now about the key components for the radio technologies. I think we addressed also most of them today, but I would like to provide here the perspective from an operator about the deployability of those ones. So ultra-dense small cells networks will most likely be unavailable at some point in the future. I mean, we don't see that coming before maybe 2025, at least 2020 something. But at some point it will come for sure. And one key element that was not mentioned a lot this morning is the cost of the sites, because each new cell, even if it's a small cell, represents a new site, and for each site, an operator has to pay a rent. So it's not only the cost of the device that matters here, the cost of the backhaul, the cost of the energy, they are also important, but just finding the site and renting it represents a significant cost. So having a large number of sites is good, but we need also to find some appropriate agreements with the owners of the sites in order to make that a reality. Then, of course, when you have a large number of sites, you need to have a good network management system, which is as much automated as possible. So the next disruption that will come is about the millimeter waves that goes together with massive MIMO, and we discussed that also today, this morning. About the millimeter waves, one key question today is on which bands shall we use? I mean, there are different candidates, and the industry is thinking at the moment about what are the ones that are the most appropriate from a regulation perspective, but also taking into account the bandwidth available and, of course, the carrier frequency, because the higher the carrier frequency and the more difficult the propagation. Also, there is a need for new channel models in order to be able to assess the performance we can expect on those bands, and there is also a lot of effort today in the industry to design the appropriate channel models. Then for massive MIMO, energy is of key importance. We discussed that this morning, but also the form factor, because most likely we will get large panels if we want to deploy massive MIMO in the low bands. So is this feasible and compatible with the constraints we have to deploy antennas on the rooftops? That is very unclear at the moment. I mean, for millimeter waves, of course, that will be easy, but for the low bands, there is a big question mark here. Then new waveforms. So you know that there are several candidates on the table, like filtered OFDM or FBMC, filter bank multi-carrier. That provides some advantage compared to OFDM. I mean, reduced cyclic prefix, better localization in frequency. But we need to be to really trade what are the benefits versus the cost of moving away from OFDM, which is something that we know very well today and for which we have implementations already well optimized. The last one is more longer term. In our view, is the full duplex, on which you can transmit and receive on the same resource. And here it seems that the technology of interference cancellation now becomes well known and well mastered, but there are a lot of issues in terms of system design because of all the interference it will create. And for that reason, we don't see that as the first release of the 5G systems, but maybe during the 2020s it will come at some point, at least for the access. Maybe for the backhaul it's a different story, and it is more feasible. But for the access, we see that as very complicated. So these are the disruptions that we see coming. But then, of course, all the concepts that we have developed so far for 4G, and which are, at least for some of them, being standardized at the moment in 3GPP, that will also be part of 5G. So you have the list here. But one thing that is important is that in 4G, those elements, they came after the initial system design. And for some of them, the initial choices that were made were not the most appropriate. If you take comp, for instance, where you have joint transmission from several sites, what you have in 4G is that you have the common reference signals that occupy different resource elements in the time frequency grid according to different cells. So if you have a joint transmission from 3 cells, you have more or less 10% of overhead if you have 4 antennas at each cell, 10% of overhead per cell. In the end, you have 30% of resource that are occupied by pilots. So it means that in order to get some performance benefit, you need already to compensate 30% of resource loss. And you cannot, the equation is that in the end, there is no or very little gain of comp because of that reason. So in 5G, we will be able to remove, if we design a new air interface, we will be able to not redo the mistakes that were done in 4G and have the system optimized from the start to have an integration of those concepts. Then I will move to our architecture proposal. So I have to say that this is a really preliminary high-level view. So maybe in 2 years from now, you will see something different. Not too much different, hopefully, but it's not finalized yet. But still, we think it's interesting to share that with you and get feedback. So first, I would like to go into a little bit more details about the requirements for the architecture. So first thing is that we need the architecture to be adapted to the new services we will get, and in particular IoT, massive number of devices. Also to be able to facilitate those big data based services that come along with machine-type communication, mainly. We will want also to decrease the cost, which calls for a more simple network. And here we find this convergence between the different access technologies. Better network resilience, of course. Then, in order to improve the user experience, we want to decrease the latency and to provide transparency for the connectivity across different access technologies. And finally, of course, support the traffic growth, which calls for higher capacity, having a scalable architecture, and also the control plane, data plane separation, which is also very important for the energy efficiency, as we discussed this morning. So this is the overall picture of our architecture proposal. Don't worry, I will explain what are those different boxes. But this is an architecture proposal which, in our view, satisfies all the requirements that we have. So the first part is to have a common interface to the core network that is independent from the access technology. So that will enable to have the fixed mobile convergence, but also this will allow us to provide support for new air interfaces in the future without changing the core network. And this is a feature that we see as extremely important. Then we have a convergence gateway that will be the anchor point for the mobility for all the access types. And we will have some chaining services capabilities. And here I'm going to explain a little bit what we mean by those services. Those services are actually network functions. So one example can be seamless mobility, for instance. And what we want is to minimize the number of network functions that are involved for each particular service delivery in order to optimize the resource usage, processing resource usage within the core network, assuming, of course, that everything is under virtualized network nodes. So the idea here is that for one particular service that is requested by the user, we call only the network functions that are mandatory to deliver that service. So if you take a machine-type communication device for a sensor, which doesn't move, it doesn't need seamless mobility. If this is a voice call, you need to have seamless mobility, handover, and so on. But for that one, then you will call the appropriate network function. So you have this chaining service function that, for each particular service, associate the different bricks that are needed to build the service. So then we have the border gateway, and the border gateway enables an operation which is extremely important for us for the 5G architecture, and that is brand new. We didn't discuss it this morning. It's about providing third parties to manage and configure their service. So one example is and all this happens using APIs that are exposed, that expose some network functions to third parties, service providers, OTTs. And the idea here is that the third parties, they can, for instance, control what's the quality of service that they would like their service to be to have when offered to the customers, and they would have a direct interface to configure that service and configuring then the network, the operator network functions in order to deliver this service under the conditions that they want. And of course, we as an operator, we expect to get revenues from that because this is a service that will not be free and that we will hopefully monetize. So the idea is to build the operator network as a platform to enable third parties to take advantage of it to optimize their own services. Then we have the orchestrator of all this architecture, which is the access, session, and service control. So this function controls the convergent gateway, but also the service chaining, and it interacts with the border gateway, and yeah, so it really manages the whole thing by controlling all those different boxes. And finally, we have the data server, which is about the storage and processing of the subscriber information, and providing the relevant interface to the access, session, and service control. And finally, I would like to have a focus on the ultra-low-cost networks, which is also something that we see as extremely important for 5G. Actually, we see it as extremely important also for 4G, but we think that when building a brand new technology, we have the opportunity to make it right from the beginning to enable those ultra-low-cost aspects. And this starts from the observation that today we have between 2 and 3 billion of people on Earth who cannot still be connected to the internet. So there are several reasons for that, but one of them for some countries is the cost. So for the users to acquire the terminals and for the operators to get enough revenue to operate a network in a sustainable, economical way. And we think that in order to provide connectivity to those areas, we need to have ultra-low-cost network infrastructure, well, okay, you can read it. Ultra-low-cost devices and ultra-low-cost operation and maintenance. What we see here in terms of offered service, this is not the conventional 5G. This is not the multi-gigabit per second data rate. Of course, if we want to have something extremely cheap, we are ready to go to some performance relaxation in order to be able to deliver that. So what we target here are voice and wireless internet access with DSL-like services. Something like 10 megabit per second would be extremely good already. And for the environments that we target, it's mostly rural and suburban areas for the regions where we have extremely low average revenue per user. The reason is that when you have a dense urban environment, for instance, you will have plenty of users there. So maybe then the case is economically feasible to deploy the full-fledged technology there. And maybe you don't need in those areas to have an ultra-low-cost technology. Also because you will have huge capacity constraints, so you need to have a very efficient technology to deliver this capacity. But for those rural or suburban areas, maybe it is not the case. And for that, clearly, you will need to have an extremely low-cost technology. So then how to deliver it? So on the next slides, we have a number of possible solutions. But the big picture is whether we should have a completely new technology or just have some options within the regular 5G technology to offer that. And our preference is to have this modular approach where we design the full-fledged 5G technology in such a way that you can remove or choose not to implement some of the functions in order to provide a minimum service, because, of course, that would ease the implementation instead of redefining completely new functions. And that may help also the economies of scale if those ultra-low-cost infrastructures if they share common elements in the hardware or the software with the regular equipments. So in terms of solutions, what we see as important is to have extended macro coverage solutions, because, of course, if we want to cover a certain wide area with small cells, it's much more complicated because you need to deploy the small cells. So from the cost perspective, having one big macro is more efficient. Simplified architecture and networks. Relaxation of network constraints like availability, performance. So as I said, we are ready to go quite far in terms of the performance relaxation because we believe that having some connectivity, even if it's not perfect, is better than having no connectivity at all. And for that, we would even go to, I mean, of course, reduced peak rate is one, but we would be ready also to go to limited availability, which means that if you don't have the capacity, enough capacity to serve all the users at the same time, we think it would be still acceptable to provide certain hours. Like, unfortunately, in some countries today, you have some hours during which you can get electricity or water supply. It's clearly not good, but at least for internet access, having a few hours of connectivity per day and with different maybe areas being served at different hours of the day is better than nothing. And this is something that would be a possibility also to have the hardware, which is not dimensioned for handling a large capacity, but in exchange of what we would get a reduced cost. Low-cost network operations, so that calls for self-operating systems, SON. Design cost is not the only aspect. I mean, having some also adapted IPR is a way to reduce the equipment. Some simplified RF design too, which also, of course, will lead to some performance degradation. But again, this is the cost, which is the main trigger here. And last but not least, some low-cost backhaul solutions, because backhaul represents one of the highest cost component here. And you may have heard about the initiatives from Google and Facebook to provide low-altitude platforms to provide the backhaul. And these are also solutions that are potentially extremely useful for this use case. So to wrap up, in our view, 5G will be the future internet, which will encompass new radio accesses and a convergent core network supporting both radio, including 3GPP and non-3GPP accesses, and wireline accesses. So we place at the top of our requirements the consistent user experience, network energy and cost efficiency, and flexibility for future evolutions. And we support 5G to offer options for ultra-low-cost networks to bring internet connectivity to the populations which are not connected today. And finally, we actively participate in all the initiatives to shape 5G, including NGMN, the 5G PPP, so which is the European framework for collaborative projects, and 3GPP, which has started to define the use cases and the service requirements for 5G. Thank you very much for your attention. And also, thank you very much for inviting me today and giving me this opportunity to participate in this really nice event. Thank you.
We have time for a couple of questions. Anything?
I have a question perhaps for you. Could you maybe elaborate on 5G vision, geographically speaking? You mentioned Africa, but we have Asia, Europe, and North America. Do you see differences in priorities of where the innovation will happen first and so on, and how do you see that?
Yeah, I think that was briefly discussed this morning. Different regions of the world have different timescales for the 5G deployment. In Asia, they are quite aggressive because there are the Olympics coming, so the Winter Olympics in 2018 in Korea and the Summer Olympics in 2020 in Japan. And so Korean and Japanese players are very keen on demonstrating some 5G service during those events that will receive extremely important global media coverage. So I mean, usually Japan also has been at the forefront of deploying new technology because they have capacity problem. So maybe it's not only about the Olympics for them, but clearly there are some capacity problems that we don't have in Europe. So as I mentioned this morning, for us, we start to deploy some small cells, but it's not thousands. It's tens or maybe hundreds. So then I cannot comment on the US. I don't know enough the market. But in a nutshell, most likely Asian countries will be the first one to deploy at least a mobile broadband 5G. Then about the other features of 5G, like enabling the Internet of Things, especially when it comes to high reliability and low latency use cases, then it will depend on the market demand. If operators feel that there is some business case there, they will go for the deployment.
I think you had your hand up before. Oh, go ahead.
I was curious as to how, as an operator, you look at it's a similar question to what we talked about earlier, but how you look at the sort of, you look at 5G as just requiring, from an operator standpoint, massive upfront investment, or if you look at it as, and then you know, this is something that it's going to take any operator 10, 15, 20 years to recover, or is it something where you can really sort of build it around what you already have and it'll be free capital positive soon?
It depends. It depends on several aspects. It depends first on the spectrum. If we have to pay billions of euros to acquire the spectrum, yes, it will be a huge investment. It depends also on, I mean, related to the new spectrum, you have also the need to deploy new antennas. If you have to deploy new antennas, it will have a strong cost. As I said this morning, we will need also to renew the hardware, but that we'll do anyway. So this one probably is not the main driver in terms of investment. So it seems that I mean it's a bit early to say how much investment it will require because we don't know today exactly what 5G will be. But already assuming that we will renew the hardware anyway, that will not be a huge investment like when we deployed 3G, for instance, at least in my perspective. But let's see exactly what it will be before being able to answer clearly that question.
Dave, and that'll be the last question.
So something I found interesting on your slide is that you're showing the session model where there's a session per endpoint surviving into this 5G world where you have 50 billion devices instead of a couple billion. Do you have any concerns that having session state on a per device model when there's 2 orders of magnitude more devices is going to be a problem?
Well, first of all, I don't know. I mean, what I showed is the functional architecture. And the way this functional architecture will be implemented in terms of where those functions will be located in terms of different products, that we don't know today. And this is part of the questions that we have to solve. So also, there is one thing about those massive sensors. It is likely that they will not, all of them, have a single connection to the network. Most likely, there will be gateways that will aggregate the signals from a large number of sensors and feed them to the core network. Yeah, so whether there will be one access session per user or whether one user here will be rather a gateway, I mean, both options are possible. And again, the way that will be exactly implemented, that isn't clear at the moment.
Okay, that's great.
Thank you.